Hi everyone, welcome to the first example of using this formula for integration by parts. Now let's imagine we had to perform the integral of, let's see, what's a good one? X multiplied by the cosine of x with respect to x. Now this expression forms the left-hand side of our formula. So we have to decide which part of this expression will be represented by u and which part will be represented by dv. Now I think let's just try. I mean, we have an x, we have a cosine of x, and then we have a dx as well. Don't forget the dx is part of this. So I could split this up in many ways, but for instance let's just start off with why don't we let u equal x and then dv, so our product is u multiplied by dv. I'll just highlight here. I'm going to let this part correspond to u, and I'm going to let all of this part correspond to dv, and that includes the dx there. So this is cosine of x dx. Don't forget that. Now if I want to successfully use this formula of mine, I need to know what u is. Done. I need to know what v is. I'll have to integrate the second expression to find v. Then v would substitute here, and I'll need to know what du as well. So I'll start off with this first bit. I'll find du by differentiating. Du dx will equal 1. And my goal is to find du, so du therefore equals dx. That was pretty straightforward. Now I also need to know an expression for v, both for this part and for this part. So I'll have to integrate over here. V would be the integral of cosine x dx. Now you see why it was important that that dx was part of this expression, so we could actually do an integral. Now what does this give us for v? Well, the integral of cosine x is the sine of x. Now I know we would normally write a constant of integration here, but we don't at this stage. So the plus c, if you like, I'll just write this over here. I know we would normally put a plus c, but because this is just an intermediate step, we don't bother writing the constant there. We'll introduce the concept back in our main working when we get to that point. If you like, all of what I've just done here could go under the heading of aside. Now let's rewrite this as the integral of, we're going to use the expression on the, don't need an integral, we're going to use the expression on the right hand side, u multiplied by v. Well, let's just think about this for a minute. U was x, so that starts off nicely enough. I'll just use my yellow to highlight there again. V. Now v is something new. V didn't appear over here. V is down here. So on the next part of my formula, I would have to write multiplied by the sine of x, subtract the integral. V, once again, is the sine of x. Just to highlight blue again, the v. Now du, that's something different. What haven't I used yet? I haven't used purple yet, have I? Du, where's du? Well, du is down here. That's why I needed both parts of this aside, and as we can see, du is the same as dx. So instead of du, I can literally write dx. And that gives me, instead of the integral here of a product between x and cosine x, which let's face it, we don't have a product rule, but we do have this integration by parts. So we're integrating each part bit by bit. See how we split them over there in the aside. Now what does this give us? Well, x multiplied by sine of x is still sitting there. Subtract the integral of sine x is negative cosine of x, and this is the part where I will add my constant of integration, because this is an indefinite integral, and so I'll need, and this is the main working, I didn't bother over there. If I had a c over there, it just would have added into this one and made a different but equally valid constant. And so I end up with x sine of x plus the cosine of x plus c. There's my integral done using the formula integration by parts. Now, crucial to success here was a careful choice of u and dv. Let's just try for a minute, at the risk of making this too long, and see what happens if we choose the other way around. So we had x cosine of x dx. Let's just imagine for a minute that this is cosine of x multiplied by x dx. Let's say that u equals the cosine of x. Let's say that dv equals x dx. So I can find du dx easily enough. Derivative of cosine is negative sine. I can integrate easily enough here. V will be the integral of x, so that is x squared over 2. I'm not going to add the c at that point. Coming back over here, remember, now if this was u, this was v, I would have to remember our formula was uv minus the integral of v du. Just write that in there for a minute. So u was cosine of x. V, it turned out, was x squared over 2 minus the integral of v was x squared over 2 du, I didn't finish there, du was negative sine of x dx, multiplied by the negative sine of x dx. Now look what's happened. We've ended up, we took an integral which was x to the first power multiplied by cosine. Did I not write x in there way back then? And now we've ended up with a worse integral with an x squared multiplied by the trig function sine of x. So you can see that by choosing u and v in this manner, I've ended up with a much worse situation, and that is a bit of a dead end. I'm not going to get anywhere there. My point in showing you this is that if you try doing an integration by parts and you end up in a dead end like this, where the integral here is worse than what you started with, more complicated than what you started with, then perhaps pause, go back and choose a different value for u and a different value for x. Now that leads to the following general idea. Now I'll just write this down first. And this means logarithmic. This means inverse trigonometric. This means algebraic. So polynomials or powers of x and so forth. This means trigonometric. And this means exponential. Generally speaking, if you have, when you've got your integral of u dv, you want to pick u in order running down this list. If you have a logarithmic function, say, and an algebraic function, then logarithmic comes first. You would let u be the logarithmic and the dv would be the part involving the algebraics. If you had a integral of something, a product of, say, a trig function and an exponential function, because trig comes on the list before exponentials, you would let u equal the trig function and dv would be the part involving the exponential function. Now this advice mostly works, and as long as you've got different types of functions. So these are the 5 main types of functions that we'll ever come across, and as long as they're of different types, this will get you the right choice for you most of the time. This little word here, liate, or whatever you want to say, is a way of choosing which function should be u. Now let's go back and look at our example here. I had an algebraic function in x, and I had a trigonometric function in cosine of x. So, algebraic, trigonometric. Algebraic comes before trigonometric. I let u be the algebraic part, and the trig part ended up being the part for dv, the remainder. As long as you make a choice for u, the remainder, including that dx, has to be the dv part. Okay, I've been going on about that for too much. A few more examples will hopefully make that clearer.